So in activity 4.3, we're given a graph of the velocity of an individual walking, and along the horizontal we have seconds. We'll call that our t-axis, and our v of t-axis. And what we want to do is figure out how far this person traveled, total distance and displacement. So here's one way we can approach this. So we can look at particular time intervals and see what their position is. Now we are given that at time 0, this person is at 1 meter from some point. Now what we're going to do is figure out their change in position for each additional second. So at 1 second we need to figure out how far this person traveled. Well, 1 second would be right here, and so our distance traveled is going to be the area of this triangle with a base of 1 and a height of 2. Area of a triangle is 1/2 base times height, so they're going to travel 1 meter. Now it's going to be in the forward direction because our function is increasing anytime our derivative is positive, so 0 to 1 and 4 to 8. This person is going in the opposite direction, backwards we could call it, anytime the derivative is negative, which happens between 1 and 4. So this person has moved forward 1 meter between 0 and 1 second. They started at 1. They're going to move to 2. And let's go to 2 seconds. Here we have a triangle, and we're going to get the area. Now it's below the x-axis. So let's mark what's going on here. This had an area of 1. This triangle also has a height of 2 and a base of 1. It also has an area of 1, except remember it's below the x-axis, so this person's moving backwards. So our position at 2 seconds, we're going to move backwards from the 2 that we were at and go back to 1. Now this is going to be different than the total distance traveled. His position at 2 seconds is 1 meter away from the start. His total distance traveled is 2 because he went 1 meter forward and 1 meter backwards. Right, so we can notice the difference. It's as if we're taking the absolute value of this, we're flipping it up above the x-axis and calculating the areas. Now let's go ahead and keep finding our positions. So for instance, here's 3. Now we have a rectangle with a base of 1 and a height of 2. So he's moving 2 units, and it's below the x-axis, so he's moving 2 units backwards. So at 3 seconds, his position is -1 meter past this point that we're measuring from. Let's go to 4. We've got another triangle with an area of 1. Again, it's negative, so he's moving backwards another meter. So he'll be at -2 at 4 seconds. We're going to continue this pattern. At 5, we have a base of 1 and a height of 2. So we got another triangle that has an area of 1. So now he's moving, but now he's moving forward because it's positive, so now he's moved to -1. So hopefully you can see the connection here. He's moving forward 1 meter, backwards a meter, backwards 2 meters, backwards 1 meter, forward 1 meter. And that's how we're getting our position. 6, we've got an interesting shape. A couple options. We could treat it as a trapezoid, or we could break it into a triangle and a rectangle. This rectangle has an area of 2. This triangle has an area of 1. So the total area here is going to be 3. So he's moving 3 meters forward. So now his position at 6 seconds is 2 meters from the original measuring spot. Here we can see we're going to get a triangle of the same area as what we just saw between 5 and 6. We can fill in these numbers. So again, this is going to be another 3 meters this person is moving forward. Finally, we've got one more triangle that has an area of 1, so he moves 1 meter. Again, it's above the x-axis, so he's going 1 more meter forward. Sorry, this shouldn't have been 3. He was at 2. He moved forward another 3 meters, so now he's at 5. And then Between 7 and 8 seconds, he moved forward another meter. He's at 6. So his position at 8 seconds, or we could say S of 8 equals 6. So that's his position. His change in position, so we're answering the questions to part C, is S of 8 minus S of 0. So 6 minus 1, or 5. So we do have a difference, and both of these are in meters. So his displacement between 0 and 8 seconds is 5 meters. His total displacement from this original spot where we were measuring was 6 meters, because he started at 1 meter before we ever started timing him. So finally, we can figure out his total distance that he traveled during this time, because we can add these up. So his total distance is going to be between 0 and 8 seconds. He went a total of 13 meters if we count both backwards and forwards. So that's the difference between distance and displacement. So this here was his total displacement. Now, let's go ahead and on our plot, make a plot of S. And we'll use a different color so we can see it a little bit better. First thing we'll do is we'll plot our values. So we can treat these as points. So 0, 1, 1, 2, 2, 1, 3, negative 1, 4, negative 2, 5, negative 1, 6, 2, 7, now we're going to go off our chart a little bit here, 5, and 8 is all the way up at 6. We'll just put a little dot there. Now, this graph's going to have some concavity, and the way we know the concavity is by what's going on with our function. Notice here we have a decreasing rate of change between 0 and 1. We would expect to have our graph to be concave down. Here we have a constant rate of change, so between 2 and 3 we'd expect our graph to be linear and decreasing. Here, look at that, we got an increasing rate of change. For those next few points our graph is going to be concave up, and we're really starting to see these connections. Now right here, our rate of change, our velocity went from increasing to decreasing, even though it's always positive. So our function is still going to be increasing, but we are going to change concavity until we get to 8 seconds, where we have a rate of change of 0, so we're probably going to see it start to flatten out. So that purple graph is a nice representation of our S of t.